Okay, now it's time for us to get started on the knurl. Here in our shop we have two different knurling tools that are available to us. We have this one here with the turn knob on the top, and we have this one here which in order to turn the top you have to actually crank an Allen wrench up and down. One is just a little bit different than the other. This particular model here, this unit here kind of floats around where you need it to be, up or down. So that makes it a little easier. So as you're tightening this unit will float up and down and go find its own center. This particular unit here is not like that. You got to actually kind of adjust it back here in order for it to take and become center in reference to where you're at with the diameter of your work. So a lot of times I gravitate to this one a little more than this one. Now these knurling wheels that are on here are set, okay, and they do wear out. So from time to time we have to replace these, you know, because they just start to get worn or galled up to the point where you just don't function properly. Our knurl is here. I went ahead and got a sample handle out. This is basically what we're going to be shooting for. We're going to make the knurl from all the way from this end all the way up an inch past where we need it to be so we can bring this on up to it, okay? We're also going to take and finish this on this end so we can cut that piece off and then in turn make the hole for that to screw in. So this will actually become this, so it'll be able to be screwed onto there like so, and that goes in like that. Now, as we go ahead and start to get it set up on the machine, we will drop this in place like so on the dovetail, cam lock it together. This has to be perpendicular to the work itself. So we'll loosen this up where we can actually move this by hand. We'll bring this on up here. We use these blocks that are on our tool cart in order to line this surface up here so that this is actually perpendicular to that, and we work off the face of the chuck itself. Now, we're going to get ready to go ahead and make this tool perpendicular to our work itself. So we're going to bring this on up, and then we can swivel this like this. We're going to push this up against there like that to where this is snug, and then we're going to go ahead and we're going to tighten that in place where now that is perpendicular to our work. Hold on to here, snug that up, get another bite, make that good and snug. Now what we have to do is we have to go ahead and put the machine in back gear. So we'll go ahead, and I tell the students go ahead and open this door so they can see what's going on. As you can see, the belts and pulleys are here, and they'll unscrew this knob and it will open this door here where these gears are. Now this is where we put it in back gear. We have to pull our lever forward and disengage our belt both here and here, and then we'll go ahead and move that belt from this pulley here on out to that pulley there. That'll in turn change this from being in, when I say back gear, I mean the low range. So it'll change it from being in high range to low range in order to put our knurl on. Now what some people say is that they can go ahead and do the knurl in high range, especially on aluminum, okay? And that may be so, but what we want the students to do is understand that they can change the speed of the machine from high range to low range, and this is where one of the places where we can do that. Now I went ahead and moved the belt from this pulley out to the front pulley and to the front pulley on the bottom as well. Now we'll go ahead and re-engage our handle, and we'll go ahead and close this up. Like so. Once we got this nice and tight, we have to turn our power back on because here again, anytime we open the lid, the safety switch here or here will kill the power to the machine. Now that we have the machine in back gear, we're going to go ahead and take our gearbox and we're going to put our feed rate in wide open. This is as fast as it'll go. Here it doesn't make a whole lot of difference, but we want this to go down here because we want the carriage to move rather quickly down the work as it's putting on the knurl, especially on an aluminum project. Okay, one of the things that's really important is we need to take the center of this wheel and make it in the center of that diameter on the work we're doing. So what we're going to do is I'm going to go ahead and crank this up here. I'm going to zoom in the camera where you can sit there and get a good look at what's going on. Okay, and when that's in the center, I want you to say stop. Keep going, I know, keep watching, Keep watching. Yeah, I heard you say stop right there. Now right there, our center diameter should be lined up with the center of this shaft here in order for that. Now the next thing we're going to do is we're going to want these wheels to not turn. So what we'll do is I'll start cranking this up. Again, this unit will self-center this way, but I'll crank these up till neither one of these turn like they are right now. Okay? Now from the back of the machine, it's the easiest to see what's going on. Okay? We're in the center. Both of our wheels are not turning. They're both snug. Okay? Then I tell students what we do is we want to set the depth. Now there's all kinds of ways to skin a cat. And if you ask people how to knurl that's done it a lot, everybody has their own technique and everyone's a little different. But at the end of the day, what's important is the job comes out well. What I want the students to do is start their knurl right at the end of the part. Because if this knurling is not 100%. It's kind of, I have all the students before they turn the on switch to see how it goes. I ask them to cross their fingers because we need all the luck we can get sometimes to making these work. And doing over 500 knurls plus since I've been here on these particular jobs, it doesn't always work out as well as expected. Now, we're going to put the Allen wrench in. We're snug there. I ask the students to bring this around and snug this up to about that much, okay? Now, we also have to make sure that this is really tight over here in the chuck, and that's what we will do next is tighten this up and double check this. Now I'm doing a little bit from the back side of the machine. I'm just double checking to make sure that's good and tight. We've hit our power back on, so we're ready to go. And we're going to turn our machine on and see what happens. Okay, I'm going to go ahead and zoom in on this. And we're going to check out our pattern on the knurl. Now, our pattern on the knurl needs to go in a diamond-shaped pattern. I went ahead and did a little shading on the light so you can see the diamond-shaped pattern on the first try come out really well. And we're going to continue that pattern on down the part. So I just wanted to let you see what a good knurl looks like. And this come out well. Now I'm going to go ahead and put this, turn on the machine, engage the lead screw down here. You can see that's running pretty fast. We're going to go ahead and engage our feed down here. And as you can see, the wheels start to turn. Even though it's turning very slow, this machine is running practically as fast as it can go in that direction. And as our knurl is running down. Now what we don't want to do is we don't want to run into this shoulder right here with the side of this tooling there. Okay? That's bad juju. If that happens, everything's going to go terribly wrong. As you can see, when we're all finished here, our knurl looks pretty good all the way down our part. What I'm going to go ahead and do is while I'm there is going to go ahead and take the gearbox out of high as fast as it'll go and move it about to that point there. That'll slow the carriage down. And we'll take and disengage our feet at the moment, put this in neutral where the lead screw here will not turn because for the next operation we won't need that. As we come over to this side of our work, we're going to go ahead and turn our machine on. And as you see, our work is spinning. But we're going to go ahead and take the burr off here. A lot of times when we do this knurl, it drags up a little burr on here. And for the next step we're going to do, it's important to get rid of that. So we always file left-handed. The file handle always goes in our left hand, and our right hand always holds on this. Okay? We never reach over the top of the chuck. I'm just taking and get rid of the burr on the end. As you can see, this is not turning anymore. So our force against this, it pushed that in there. Now we need to make that start turning again. I'm going to go ahead and brush our chips away that we got on the inside there. And we're going to come on, bring this in where we give a little snug and make this back turning again, where if you put your finger on it, you can't stop it. Okay? The next part of our operation is we're going to go ahead and use our parting tool, grooving tool, cutoff tool. It has a few different names depending on what you wish to call it, but the purpose is just all the same. We're going to go ahead and touch this side of our parting tool, okay, on the end of the part, and we're going to move it up 1 inch from here to there. And then we're going to go ahead and plunge that groove in to the diameter between 0.26 to 264 thousandths as a low to 274 thousandths as a high. That's how big around we want that groove. Instead of working off the tolerance in a tolerance block, we gave specific dimensions in between those two are what we want it to be. Again, we'll take our parting tool and we'll go ahead and drop it down in there. Again, this is regulated by this up here. This stop here regulates how far down this will go to locate for center. And we'll lock it in place. Then we're going to bring it up here. We're just going to double check it as far as centers go. As far as center goes, we want that on center to just a tad below. One of the ways we're going to check that for center is we're going to go ahead and bring our center out back away from our work. We're going to crank this in and we're going to see just how we look in reference to the center. I'll go ahead and zoom in on that. And we look like we're just a tad below center, okay? And that's going to be acceptable, okay? A little below is better than above. Now, what we're going to do is we're going to very carefully bring this up and we're going to very carefully touch that against the work just like that, just where we see it touch. So we don't forget, we're going to go ahead and bring our center back into play and screw that back in snug. Now, on this side of the machine, I'll show you what happens. As we brought that up and made that touch where it belongs to be, okay, now we're touching the side of the tool to the end of the part. This has got a friction thimble on it. We can take and bring this around till we make this a 0, okay? We're at a 0 setting right now. If we bring this off, every mark on this dial down here, every single mark is 20 thousandths of an inch. So that would be 20, 40, 60, 80, 100 thousandths, okay, at this point here. 200 thousandths, 300 thousandths, 400 thousandths, 500 thousandths are a half an inch to there, 600 thousandths, 7, 8, 900 thousandths. Bring that up to a 0, 1 inch. If we go past, we can't magically come back like that and it's good. There's play in the handle. So we have to come back here, that's the backlash. And then bring it back up till we get to a 0. Now that it's at a 0. Now we're exactly 1 inch from the end of the part to a 0 dimension. Like I was saying, we're 1 inch from the end of the part here, okay, up to the side of our cutter there. So we're going to go ahead and turn our machine on. Make sure that that's spinning back here. This here guy's spinning back here. And then we're going to go in and we're going to sort of cut some of the knurl away. Now once we get to a clean finish here, I'm going to go ahead and shut the machine off. Like I said, this is not recommended normally, but I want to show you what's going on. Aluminum is much more forgiving. If this would have been steel, this insert might have chipped or broke when I just did that. I went ahead and backed this out more so that we had plenty of room between there to go ahead and measure. I'm going to go ahead and put our calipers in. We're going to use just the last little part of the calipers because we have no choice, because the groove we're putting in is basically about the same thickness as the calipers themselves. So we're going to go in there and measure. It looks like we're about at 601, 602 diameter on our dial here. So that's what we're going to go with. What I'm going to do is I'm going to shoot for taking off 300 thousandths off the part, which should still leave us 27 thousandths for finish. So how we'll do that is we'll go ahead and turn the machine on. We'll come up to where we left off, should be at a 0 mark. If we look down at our part here, it's at a 0 mark. So let's start taking off 300 thousandths. So 10. Our measurement is right at 300 thousandths. So right now we were at 300 thousandths. We're going to the high side, 274. 274 from 300 leaves us 26 thousandths left to take off. We're going to go back into where we left off, and we're going to take off 26 thousandths. So we come around to 0. Remember, every mark takes off 2. So 5 is 10, That would be 20, 22, 24, 26, and we're going to take just a little bit more. Re-zero this. Back out, and we're going to measure and see what we got. As we go in and measure with our calipers, it looks like we got about 271 is what we got on the calipers, so that part is good and in tolerance. Now, we're going to go ahead and change out from the grooving or parting tool, since our groove is good, and we're going to begin to turn this diameter down here, and we're going to use this lathe tool right here. Again, we're going to drop that in place, bring it down and lock it in place. We can pull out our center if we want, bring it on here, do a little check on to see how we are as far as height goes. We're just a tad below center, which is good. Bring our center, make sure our center's clean. Bring our center back into where it goes, snug it up, and we're going to begin to turn this diameter down. Now what we're going to be doing next is we're going to be turning the diameter down on this cap. We're going to be turning this diameter down right here. That would be this part here, between 365 thousandths as a low to 370 thousandths as a high on that dimension there. That's what we're going to be working on next. There's going to be several things we're going to be doing, so we're backing off the camera now to get kind of a broad view. We're going to go ahead and engage our lead screw here. That is done right here. We pull the knob out and go up. The feed we got it on is a good running feed for turning the diameter. We're going to take and also come in here, bring our carriage back, bring in till we're close to our work, make sure we're locked in place, turn our machine on, make sure we're spinning there, our lead screw's turning. We're going to be off the work now just to give a check to see we're going in the right direction. This is not going. Okay? I pulled back on this just to bring our backlash out of everything. When I pulled back on this, everything kind of clunked back. Okay? We're going to come in till we touch, come off to work. It's going to make a vibrating noise in the beginning as we cut that knurl away. It doesn't really matter. We're just going to take a cleanup cut across it because we know we got quite a bit to go. I'm going to put a 0 on our dial here and engage the feed. I shut it off when it gets to the groove. I make sure that we're set on 0 here. We can, if we like, just go back across it like that. That's fine. Kill our machine. We're going to measure and see what we got. We're going to go ahead and take our calipers, turn them on. 0, make sure they're zeroed out. Just double check to make sure they're clean. Come in here. Go ahead and I kind of lean them a little bit whenever possible. 585 is what we got. That's what we're working with. Okay, when we come over here at 585, we're shooting for the high. That'd be 370. 370 minus from 585 leaves us 225 to take off. Always remember that the dial takes off 2 thousandths for each mark on the dial. This is where we left off at 0. Okay, 20, 40, 50. We're going to take 50 off at this pass. Bring this back around up to 0. Turn our machine on. Bring it up around here where we can see what's going on. We're going to engage our feed. We're taking 50 thousandths off. Shut our machine off. We look back around. We can see we've still got our dial at 0 because we set it. Okay, we're going to crank our carriage back away. Come on across. Okay, we're going to take off another 50. Come back to 0. I went too far. We're back where we left off. 20, 40, 50. Set our 0. Take another pass. That makes this taking off 100. Okay? We're going to come across. Okay? We're going to take off another 50, 20, 40, 50. Re-zero our dial. So that means we're taking off 150. We're going to stop at 200 and check to see what we got. Okay? Shut that off. Bring it down. We're going to take off 20. We're going to take off 40. No more than 40. Okay? Just to be safe. Okay? We're going to come over here to our gearbox. We're going to take and drop our feed weight down a notch to get a better finish. I say that. Get in gear. Come on. There we go. Come back around and up and over. Engage our feed nice and slow. We'll see what we got. I'm going to stop it right there because I want to be careful to see, make sure we don't make a mistake. Shut it off. I know, get the paintbrush out. Brush our chips away. Let's see what we got going on. I had checked ourselves. We were 389, so we're good. Go back here where we were. Shut our machine off. Okay, we're about at 392 is what we finally wound up with. Okay, take a reading. Right at 370, 369. Very good. Okay, now what we're going to do is we're going to get it set up to put the threads on this particular portion of the part. So we'll take our wrench, we'll come underneath here, we'll crank this on up out of our way, loosen this up, bring it back. We're going to get our live center out of here, we'll crank this back till that pops out. Okay, we're going to go ahead and bring this, say, up here, where this will still spin at the moment. We're going to put a chamfer on there. We turn that on. Let's kill the noise. And we're going to file left-handed and put ourselves a chamfer on the end. Like that. Okay. Shut that off. Any little debris on there, we'll just scrape that out of our way. Now we're going to take this particular piece here and run it up between our two jaws. Okay? All we want to do is we just want to keep this from spinning. See how it rocks back and forth? We're going to just crank this in till that don't rock. No pressure on this, just keep that from turning. On our threads, we're going to put 3/8/16 threads on there, the full length of that shaft. Now what I've done is went over to the tool cart and I read on the button die itself, okay, what size it is. This is a 3/8/16. I don't know if you can see that or not. It's real fine and hard to see, 3/8/16. And that's what we're going to use to put threads on there. Now while I got you over here with a close-up, one side of this has got more lead on this thread, like an angle, than the other side. Generally speaking, it's the side that's facing out, and it'll have more of a greater angle on it. That goes on first. And because we're going on to a shoulder, okay, after we get that on and take it off, we're going to have to reverse it and put it on the other way, because there'll be one thread right up here in this area that's not finished. And we want to make sure that we get it done, because what helps us on that lead to get started will also hurt us on our finish up here. Now, to put our threads on, we're going to use the tailstock here in order to take and line this up. The reason for that is, when we put this on, this lines it up to make sure that our threads are going on correctly and straightly. We'll push on the back side of the tailstock back here in order to put pressure there and then crank this around and put our threads on. Now, we'll go ahead and put a little bit of cutting oil on there. We'll go ahead and line this up. We'll put this against, and then we'll start to turn this on. like this. What I tell students, a couple, 3 threads till we get it, make sure it's going straight. We pull this away. Then what we want to do is crank it this way, and if you watch, little chips will rain out of there as we break them off. We give it a turn, we break off the chips. Give it a turn, break off the chips. Give it a turn, break off the chips. Give it a turn, break off the chips. Okay? Now I'm going to go ahead and do that up. I'm going to try to fast forward it on the camera after we're done to take and do that. Equal pressure on both sides of this, okay, as we go along, because you don't want to influence this or bend this part in any way, shape, or form. So I go like that, go like that, go like that, go like that, go like that. Doesn't hurt to put a little more oil on it. Okay. Go like that, go like that, go like that. Now we're all the way up on there. Spin it off. Now, we got all kinds of debris in there that we're going to blow out with the air nozzle, go shh, and get rid of. Now the debris is all gone out of there and it's all nice and clean. We're going to put a little more oil on there. We're only going to use this so to line it up to get it started, but we're going to put it on this way now. So we push it up, push it on very gently. We get that started straight. Then we're going to run that all the way up. And there'll be 1 thread or so that's left not finished. Well, it'll get tight, then all of a sudden it'll go loose. Okay, got that all the way up to where we're done. Okay, all finished up. Threads are good all the way up to the edge. Okay, that's done. Now we're going to take our live center, go ahead and put it back in our tailstock. Make sure that's cleaned out, especially after this operation. Sometimes a chip gets stuck in there. Put it in place, make sure it's there. Bring it up till we're up against. Only about a finger distance sticking out max. Tighten this up, nice and tight. Give a little crank on the tail, make sure it's in there snug. Pull this away from our chuck, give our chuck a spin, make sure nothing's going to hit anything. And we're good to go for the next. Now for the next operation, we're going to go ahead and put our parting tool back in there, and I'll show you what we're going to do. Bring this out away from the work where it'll drop down. Our parting tool is good as far as the center goes. Our perpendicularity is good because we didn't change it when we've been taking tools in and out. But we're going to double check that in just a moment. We're going to bring this on up to here, up to the headstock. And what we're going to do is run it up and see how the face is doing up here to make sure it's nice and straight and square against this face. It is. We're good to go. We're going to take this side of the parting tool or cutoff tool, and we're going to touch it very gently to the side of this right here, and we're going to put an indicator on here to zero this, because our next move has to be pretty accurate. In this particular operation, you can get a lot of criticism for what we're doing. People would say you could take the parting tool and cut this cleanly, cut this completely and cleanly off. But we're running a live center in there. And the people that are inexperienced working on the machines, running a live center in there and cutting that completely off is bad juju. Because in a lot of cases what happens is this snaps off of there, and as a result of the pressure that's being placed with this parting tool or cutoff tool, everything goes horribly wrong. So what we usually do is we usually cut the diameter down till it's about the size of the one right here in this groove where this is. And then we go ahead and hacksaw it off the rest of the way with everything away from the part. It gives the students a little bit of an experience with hacksaw, which way they may not have, and in most cases they don't. And it also gets them some experience with the parting tool in reference to going in and cutting something off, but yet not cutting it off. We are going to take this parting tool and we're going to touch it to the side of the part here. And then we're going to go around the snurl and put it over there. So the parting tool is 1/8 wide thick, and the dimension is 188 right there. So 120 plus 188 is the distance we have to travel after we touch the edge of this to the side of that. Again, like I said, 120 plus 188 equals 308. That's the distance we have to move. Okay, what we're going to do now is bring the edge of that cutoff tool right up where it touches. Now, what I tell students to do sometimes is they can put a piece of white paper behind there. That really helps to see what you're doing. And we're just going to bring that up till it just makes contact right here at this point. Then we're going to come down here. We have placed an indicator against there. Now, this indicator's got a magnetic base on it. And I'm going to move it around down here on the bottom and then bring it back up. And then I'm just going to run at any old particular place and lock it in place. Now I've locked it in place with the turn of the magnet to turn it on, and we're going to just zero this out. Now every mark on this indicator represents 1/1000th of an inch. Now we have to move that 308 thousandths. So we're going to come back up here and see that we've cranked away from our part, okay, where we don't run into anything, and then we're going to come back down here and watch our indicator. Now get a little closer on the indicator where we can see what's going on. Run it in just a smidge more on the close-up. Okay, now we're going to run it up to 308. It's set on 0 presently, so that would be 100 thousandths, 200 thousandths. Now 308 is what we're going for. That's 308 thousandths. Now it's better to be a little more than a little less. Okay, so let's run it up. Let's run it up to about 310. And now we're going to come back over here to our tool. We're 310 thousandths from here to there on this side, but that gives us our dimension we need of 188 across the width of that. So we'll turn on our machine and we'll begin to go in there. We always make sure that this is spinning back here. Remember, that's bad juju, especially now. If this is not spinning, bad things are going to happen. Okay, so we go in here, we begin our groove. Now, the idea with this groove is to make this groove by eyesight approximately about the same size as the groove on the other side without cutting this completely off. An experienced lathe hand would probably go ahead and cut it off, but he would understand the ins and outs and goods and bads about doing that. If all this gets into a bind with this tooling in there, this could all go very, very badly. But as long as we don't cut it off all the way, everything should be just fine. So we're going to go ahead and bring this on in, just giving it a steady pressure as we feed it in to make that groove go across. The cutting tool, the grooving tool is cutting nicely. It's looking good in there. We're coming close to where we want to be, a little bit more. Okay. Right there, we're going to call that good. Okay, we're not going to go any more on the diameter because that's tempting fate. That would be bad juju. Now that we have that process done, we're going to go ahead and find our wrench. There it is. Loosen our tailstock up. Slide this out of the way. Take our parting tool out of the way. Disconnect our indicator. Take it up. Make it go out of the way for the moment. And we're going to bring this over here. Now, one of the things we want to do is we want to take and go ahead and deburr this on both sides while we have it up here. So we'll turn the machine on, we'll take our file and give it a little chamfer there, little chamfer there. That looks good. Now, we're going to take our hacksaw and cut that off the rest of the way. Now, what I tell the students is this, is when the machine is off and it's not going to be turned on for any reason whatsoever, it's okay to hacksaw right-handed, okay? A lot of children, or students, don't know how to hacksaw. So what I explain to them is you're not trying to lean into it and rock with it like this. What you want to do is you want to get a flow going with your arms. The straighter you hold this, the happier you're going to be, okay? Because if you try to push it and force it, you're doing more harm than good. It's better to take advantage of most of the full stroke of it, and when you're almost cut off of this part, you're going to hear the sound change. So as you go along, I'm going to make sure I'm on here. I am. Okay? That sound changes. I take and break it off like that. There's our part. Now we're going to cut this off at a later operation in our thing, and we're also going to trim this to the appropriate length. But this part right now is done for the moment. We're going to go ahead and put our turning tool back in. We can only turning or facing, depends on the angle you set it at. We're going to put that back in the holder. Remember, cams up, cams down. Drop that in till it comes to the stop. We're going to take it and loosen this on top up here. So we're going to go ahead and, like I always say, I'm going to grab a hold of it here as I push on that there, loosen it. We're going to give it a little bit this way. So that way we just cut with the point, because we're going to make that smooth like we did in the beginning when we put our center in. Then we're going to bring this on up here, crank this on up this way, bring that on up that way. Okay, now we're going to go ahead and face this off on the end. So we'll go in here, we'll touch it like so, we'll bring it on out, we'll make it nice and smooth across the face, like so. Okay, we're going to take our file that we have, going to give a little chamfer on there just so we did. Okay, good enough. Okay, we're going to go ahead and get ready to center drill. Okay, we're going to get ready to center drill, so we'll go ahead and take this on out. We're going to run our carriage up here to get it out of our way. That's plenty good. Make sure that spins. Put this over here. Okay, we're going to clean off our drill chuck tang. We're going to slide this up, make sure that's all clean inside. Push that in, not good enough yet. There you go, that works. Loosen this up, take that out. Find our center drill. Put our center drill in there. It doesn't matter which end it is. We want it sticking out our center drill about that far, about a finger distance. Take it, snug that up good and snug. Bring this up to where it comes close. We're going to tighten up our tailstock. Turn on our machine. If we want, we could put a little dab of oil in there, wouldn't hurt. Come up here. Now, on this center drill, it's not as critical to watch how far you put it in. If you put it in a little too far, it's not going to be that big of a deal. But when you're running off of a center, it is. The center drill is just to locate where the drill goes. That's plenty good. I just eyeballed it to right there. If it's a little more, a little less, it's not going to be that big of a deal. It's just to get the drill started in the right direction on center. That's why it's called a center drill. Okay? Okay, we're going to go ahead and put our drill in. Now, several different ways you can do this. We're just going to go ahead and scale how far the drill's to go in and make a Sharpie mark on there, and we're going to drill that deep. A little bit about drills. When it comes to drills, and they say to drill so deep, okay, they're not talking about from the edge here, okay? They're talking about where the drill is full size. So where the drill is full size, the diameter, if they wanted, say, 2.5 inches deep, it's not 2.5 from the nose, it's 2.5 from where it's full size back. That's how much they want it. Now, I went ahead and put a Sharpie mark on there as to how deep I got to go. I'm going to go ahead and tighten up my tailstock. I'm going to turn my machine on. We use a white soluble oil, which is nicknamed in our shop Pigeon Milk, and that goes back to different various shops that I've worked in over the years that have the old toolmaker story of how this became to be called Pigeon Milk. But we'll go ahead and start it out here. And I'm sure that Pigeon Milk is a regional thing that they call this. Okay? I tell students on the crank back here at the handle, 1 Mississippi, 2 Mississippi, relieve your chips, squirt the hole. Come back up, 1 Mississippi, 2 Mississippi.
Breathe out, squirt the hole. Okay, now, if this drill would start to slip or move in any way, shape, or form, what you can do is you can take your chuck key and put it in there, shut the machine off, put this in as a cheater bar, and snug this up even snugger and tighter. Okay? Go ahead and turn it back on, pick up where we left off. 1 Mississippi, 2 Mississippi, relieve the chips. I also tell students, when they get about halfway up the drill to where they want to go, is to come get me. 1 Mississippi, 2 Mississippi. Come out, squirt the hole. Okay? Come back up to where they left off. 1 Mississippi, 2 Mississippi. Squirt the hole. Okay, now, what you want to do at this point is I tell them they want to get into a rhythm. Loosen this up, okay, where this will slide. Okay, slide it up in there, snug it up. 1 Mississippi, 2 Mississippi. Loosen this out, slide it back, squirt the hole. Slide it up, tighten this up. 1 Mississippi, 2 Mississippi. Loosen it up, slide it back, squirt the hole. Okay, slide it back up. slide it back, do a little tap on there, squirt the hole. Slide it back up, snug it up, 1 Mississippi, 2 Mississippi, slide it out, squirt the hole. We're just about where we need to be, okay? Slide it up, snug it up, 1 Mississippi, 2 Mississippi, look, that's where we need to be, right there. Clean it out, tap this.
Squirt, we're done. Finished. We're down to depth. Okay, we're getting ready to tap the hole now. This is a countersink that we use to make a countersink or make a chamfer at the top of the hole so it helps start the threads and get them going. All of our taps, we tell the students they have to read on the tap as to what they are. This particular tap is 3/8 16. I'll try to get it where you can see it. It says on there 3/8 16. Okay? Also need a tap wrench. These are really good Starrett tap wrenches. I like them a lot. This is what's on our tool cart. They'll go in there like that, and then you snug them up. This particular taper is going to work in our best interest, and I'll show you why in a minute. That's on there specifically for a special purpose. I've went ahead and taken the drill out of our drill chuck here, and we're going to put this in. We have a handful of these on our tool cart. This little thing has got a little taper on it that matches the taper on this. This is to help guide that tap to keep it in straight for when we start the hole. First we need to countersink this. Make sure our chuck can turn on our machine. Now I tell all students to grab hold of this as tight as they can and just push on it. Okay? What that does is that puts the chamfer on the end of the part right there. Yeah, I just want students to understand that this can be done by hand and doesn't necessarily have to be put in there. Just to get them out of the feel of some of the things they can do. Now, we're going to go ahead and put this in our tailstock. Hand tight is good enough on this. It's just a hold to keep it from going anywhere. We're going to shut this machine off. Then we're going to take our tool post here and we're going to block it in like we did before when we did the threads on the other thing. We will bring this up till it's close. Bring that up till it comes in there. And what we just want to do is bring it in to where it just keeps that from turning. We don't want any pressure on this whatsoever. We're going to put some cutting oil in the hole. Okay? We're going to bring our tap in to there. Bring that center up till it goes into the center. We're going to push on this, and the same holds true. We're going to get this started with 2 or 3 turns, getting it into the hole. Okay, now once it's started and it's flat against here, we can pull this out of the way, and we can take and go like this. We want to take and go across, break the chips. 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 Now, on all taps, when it says 3/8 16, the 16 means how many threads per inch? Half, 20. 20 threads per inch. Quarter, 20. 20 threads per inch. 1032, 32 threads per inch. Okay, so if we want to go an inch deep on a 3/8 16, that interprets into 16 threads deep. Okay, what I tell students is go in a ways, count them. 1, 2, 3, 4, 4 threads that have come out, okay, ish. Okay, 4 from 16 leaves 12. 12 more turns we got to go to take and be deep enough. So we put our tap back in, okay, put a little oil on it, put our tap back in.
12 more turns. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm going to stop at 11 and double check it. 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's call that good. 16. 16 turns it out. That makes it 1 inch deep.